Okay, we are going to get started on CN2 Assignment 1. That is where we do our vector triangle using the radar transfer plotting sheet. So the first 5 are on the plotting sheet, and then the second 5 are on the chart. So let's get started. So on all of mine, I like to make sure I have my table set up. So I have my made good, my boat, and my current. So my made good is going to be my course made good and my speed made good. My boat is going to be the course that I'm steering, my heading, and my boat's speed. And then I have set and drift for my others. So here's my little table, and I'm going to fill in what I can. So it said you want to make good 080. So I want to make good a course of 080. That's what I want to happen. So I know that's there. It says you run at a normal cruising speed of 10 knots. So that's my boat. I run, meaning my engine runs, or with my sails, I run at a typical speed of 10 knots. So that's my boat. And then I have a set, what got this in the past or calculated it, I have a set of 140 at 4 knots. So now I'm going to plot this triangle. So what is from the center is my made good and my current. So I know my made good is 080. So let's start with that. Somewhere along that line. And then I have a set of 140 and a drift of 4 knots. So let's find 140. And we'll find 4 knots. So if I make this in an hour, in 4 knots, or in 1 hour, going 4 knots, I would travel 4 nautical miles. So I'm going to use this 12-mile scale and find 4 nautical miles. It's going to be right there. So I'm going to find 4 nautical miles right here. So now I need to find my last point of the triangle. The other piece of information that I haven't written down yet was this 10 knots, and that's my boat. I know my boat does not start from the center, so it must start from the other one. So I'm going to measure 10 miles, because in 1 hour I would travel 10 nautical miles. And then I'm going to see where it crosses my made good line. And it crosses right about there. So now I have 3 points of my triangle, and I just need to connect them. So in order to measure this angle, I need to bring it back to the center. And of course, I didn't make it long enough. So there we go. So if this is my made good line, this is my current line, and this is my boat line, I want to know what course must I steer. So what is this direction? And I paralleled it up so I could measure that direction is going to be 060. Then I want to know what my made good speed is going to be. So I need to measure this speed for this distance, and then convert it to speed on the 1 hour, and I know that will equal it. So I have 11.35. So my speed made good is 11.4 knots. So I can use that 11.4 to calculate my ETAs and that kind of thing. And then my boat will be steering 060 in order to make good this. So my boat's going to be steering this way and traveling along my made good line because the current keeps pushing me this way. So that's number 1. Okay, this is number 2. And I've made my little table, and now I need to fill it in. So number 2 says I am reaching at 6 knots. So that's going to be my boat. My boat is plugging along at 6 knots. So my boat is 6 knots. I want to make good a course of 240 degrees. I found that my set and drift is 280 at 1.5 knots. So I want to make this my vector triangle. So we're going to plug in what we know. I know my made good and my current start from the center. So I can start with those 2 values and then go from there. So 240 is my made good. There's 240. I have a set and drift of 280. And now I need to put in 1.5. So I'm going to use this 12-mile scale again. And I'm going to find 1.5. Okay. So this is going to be my current line. And this line here is going to be my made good or overground. So I have 2 points of the triangle. Now I need to figure out where my third one is. The last thing that I know is that my boat is going to be going 6 knots. So let's find 6. Connect the end point to the line. So there I have my final point of the triangle. So when I connect these, that's going to create the boat line. And then in order to figure out what heading I'm going to be using, my course to steer, I'm going to have to parallel that line to the center so I can measure it. So let's connect and then parallel. Okay. So now I see that the boat, if I want to make good this, and the current is pushing this way, I need to steer into the current just a little bit, so that makes sense, to travel like that along my made good line. So the course I want to steer is going to be 240. And then the other piece of information is what will be my speed made good. So I can use that for my ETAs. So on my made good line, what is the distance? And then I can convert it to speed. 7.1. So that is my speed for my made good. And that completes my vector triangle. Okay, let's do number 3. Okay, so this is number 3. And I have my made good, my boat, and my current. It says you want to make good a course of 320. So I want to make good 320. And you want to make good a speed of 11.5. The set is 205 with a drift of 3 knots. What should my course and speed be? So I need to figure out what I'm going to do with my boat to get my course made good and my speed made good. Maybe I have an ETA that I want to make or something like that. So let's plug in what we know. Both of these start from the center. So we're going to be connecting them and starting them from the center. So let's do 320. And my other one is 205. I'm going to put in my distances. I'm going to set it for the hour. So in 1 hour, I'll be going 11.5 nautical miles. So let's find 11.5. And then my drift was 3 knots. So in 1 hour, that's 3 nautical miles. Okay, so I have my 3 points of my triangle. This is my made good. This is my current. So when I connect these two, that is going to become my boat line, not from the center. So let's connect it and see what we get. We always have to parallel it to the center so we can measure what course that is for our course to steer. Okay. So if this is my boat and I want to make good this, the current is pushing me down like this, so I need to steer into it. If this is what I want to make good, I need to steer into that current. So that makes sense. I want to steer a course of 332. And then what speed should I be doing? I need to measure my boat speed. This current is almost on my beam, but a little bit on my bow. So I'm probably going to have to go faster to fight that current. Let's see what we got. We are over 12 miles. So I'm going to use, what scale am I going to use? I'm just going to take away 6 miles from it so I can measure the rest. There is 6. Oh no, we're on the boat. Measuring what my boat is doing. That's 6. So what's my remainder? Is 7.1. So that would be 13.1. So this distance here is 13.1 nautical miles. We can convert that to get 13.1 knots. My answer, I got 13.0, but that's okay. Very close. So we did the double check. If I want to make good this, the current is coming this way. I will need to turn into it and go a little bit faster to have my made good speed and made good course. Okay, that's number 3. Okay, so this is number 4. We want to make good a course of 0, 1, 5. So I want to make good 0, 1, 5. So that's my made good. And then it says I want to cover a distance of 7 miles in exactly 1 hour. So that would mean I want my speed to be 7 knots. And that is my made good. I want to cover that distance in exactly 1 hour. So I want to make good a speed of 7 knots. We have a set of 0.50 and a drift of 1.5. What should my course to steer be, and what should my boat's speed be? So we're looking for boat. This is my boat line. And we have my made good and my current line. And those are the ones that start from the center. So we can plot from here. Let's use the roll plotter. So I'm going to plot my first one. 0.15 at 7 knots. And 0.50 is mine. Okay, so I have 7 knots, 7 nautical miles in 1 hour. There's my 7 and 1.5. So this is my made good. This is my current. And when I connect these, I will get what my boat is doing. So let's connect those and see what we get. Use the roll plotter. Bring it back to the center. Okay, so if I want to make good that course line, and my current is pushing me this way, I need to steer into the current. So having my course be a little bit to the left makes sense. So having my course, I'm going to call that about 0.60, 0.70, somewhere in between there. 0.07 or 0.06. Yeah, 5, 6, 7. And then I want to know what my boat speed is going to be. So I'm going to connect those dots and I get 5.9, which is going to be a lot slower. because that current is helping me. It's coming from behind me. So I don't have to go as fast to make my 7 knots. So yes, that makes sense. And that's what we got for number 4. Okay, so for number 5, I've set up my table and we're going to fill it in. It says you wish to make good a track of 260, so I want to make good 260, and I want to speed made good is going to be 6 knots. My set is 190 at 1.5. What is my boat's course to steer and speed? So boat is what we are looking for. That's our question. And these two start from the center. So let's plot them. 260 and 190. Let's use the scale of the 6 because we will fit inside of it. So I'm going to make sure I'm going to use this scale. So I know that the end, but we can measure here, is going to give me my 6 all the way to the end, and that's my made good. So I have this and this. This is my made good. And then this is going to be my current at 1.5. So making sure we stay on the same scale. There's 1.5. There's the end of the line. So this is my current line. When I connect these, I will create my boat line. Connect these up. There's my boat line. We'll parallel it to the center to see what my new course will be. So if I want to make good this, my current is pushing me down, pushing me this way, I need to steer into it. So in order to make that good, I need to steer into it, and that makes sense that my new course will be pushing me a little bit to the, or I need to steer a little bit to the right in order to get my made good. Forgot the 8 there. Okay, so my made good 270, 275, 280 is going to be, or excuse me, my course to steer to have my made good is going to be 274 degrees. And then I need to measure my boat to see what my speed will be. Using that same scale, 0 to 6, I have 5.7. 5.7 knots. And that is our number 5. And now we're going to do our next 3 on the chart. So let's get started with that. Okay, so we are on our training chart. And for number 1, we're departing Breton Reef Light. So we have the light, and we depart at 9:45 on a set course and speed. So that would be our boat's course and speed. And then we get a fixed position, and we are looking to see what our set and drift was, and also what our course made good and speed made good. So let's plot what we know. So we departed Breton Reef Light at 9:45, and then we set a course. So this is like creating our DR for 10:45. So we set our course for 110 at 8 knots. So let's find 110. There we go. There's our 110 line. So we set a course here, 110 degrees true at 8 knots. So in an hour at 10:45, I would have traveled 8 nautical miles. So let's find 8 nautical miles and see where we would end up. So right here is my DR for 10:45. So that's where I think I'm going to be because I have a course and I have a speed. But at 10:45, I fixed my position somehow and I got a Latin long. So let's see where we actually end up. So that is my Latin long at 10:45. And this was my DR at 10:45. So let's create this triangle again. So we have 3 dots. We have my DR, we have my actual position, and we have my starting point. So if we connect these dots, just like on the plotting sheet, we can see what we were doing. So this line, what my course and speed was, is what my boat did. And if I started here at 9:45 and I actually ended up here, this is going to be my made good line. And then if I have my last little line of the triangle is going to be my current. So I get to find the difference here between my DR and my actual position is going to be my set and my drift. So let's measure those things. They wanted to know what our set and drift was. So I'm going to measure my set and drift. And before I write this, if I ended up here, but I thought I'd end up here, generally speaking, which way is my current pushing me? Well, I thought I would be on this line, but it pushed me to the south. So my current would be pushing me from the north to the south. So my current is going in that direction, coming this way. So I know I'm going to be somewhere in between 180 and 270 on the compass. So when I get my line here, oh, you can't see it. Can you see it if I do it this way? Yeah, you can. Okay. There we go. Okay, so I have my line here, and then I'm going to read it up here. So I either have 7, 0, 7, that's 5, 6, or 5, 2, 5, 6. And I know it's in that quadrant down there pushing me from the north to the south. So I have a set of 2, 5, 6. I count my little ticks. So I have a set here of 2, 5, 6. And then I'm going to measure that distance. And I've set this triangle for the hour, so I can convert very easily my distance to a speed. So I have a distance of 1.3 knots. I'm checking my answer here. A touch off, but maybe I've plotted slightly different. That's fine. And then it asks, what was my course made good and my speed made good? So if I started at 9:45 and I ended here, what actually happened? What was my made good speed and course? We'll be able to read this one? Not quite. Let's try this way. Yeah, you'll be able to read that. Okay. So line up my two lines here, or my two dots, if you will. And then I'm going to read my course. I'm going headed this way. So I'm going to be 1, 1, and that's about 115, 116. So my speed made good, my course made good was 116. Let's find what my speed made good. I can see from here that it's going to be a lot slower than that original 8 knots. But let's see how much slower. I got 7 knots. So 7 knots was my speed made good. So that is our vector triangle on the chart. So we got the difference between our DR position and our actual position to find our current. Okay, now let's do number 7. Okay, so for number 11, this is a little bit of a tricky one. I did throw this at you. But we are starting in Buzzards Bay. So here's Buzzards Bay. And we depart buoy 11. So that's this buoy right here. We are headed out to sea, departing Buzzards Bay. At 12:20, you pass very close to buoy 11. And then we are steady on 220 at 4 knots. So let's plot 220 4 knots. Okay, I'm going to have to actually move it. There's 220. So here's my course of 220 at 4 knots. So that is what my boat is doing. Then it tells me at 1300 we are a beam and we get a 6. This is your log entry. So in order to plot this, I want to find what my DR would be at 1300. So if we're very close to this buoy, we left this buoy at 1220, where am I going to be at 1300 with this course and speed? So we have 1300 minus our 1220. We're left with 40 minutes. So at 40 minutes is my time. My speed is 4 knots. How far would I go? I can't do my automatic one because we don't have an actual hour. It's only 40 minutes. So let's do the magic circle here so it can fit. We have 60 DST. My distance is my question mark. My speed is 4. My time is 40. So we have 40 times 4 divided by 60, and we are left with 2.66. So my distance is 2.66. So let's find .66. Excuse me. Oh, I can't see this. Okay, so this is 2.66 miles. So right here, where that little 42 is, that is my DR for 1300. So that's where I think I should be at 1300. Now it told me in the question that I am a beam of the tower and I get a 6. My log entry says 1300. My bearing is 310 at 2.5 miles. So I also know that I'm a beam. This is the tower at West Island. So I can do, let's do 310. 310. Get it lined up. So I have my 310 line. Now I could have also done, I said it was a beam, so I could have used that line and just made it a beam line. Either or is fine. So I have my beam line, and then my distance was 2.5. So let's find 2.5. And that puts me from the light right on my track line. So here is my actual position at 1300. Now, what I have here is not a triangle, it's a line. So that tells me it's either a following or a head-on current. So I want to figure out which one it is, and then by how much. What is my actual current? So if I thought I'd end up here, but I actually ended up here, that current is pushing me, and it's pushing me by a lot, right? So it's pushing me even faster because I ended up further down my track line than I thought I would. So I know it's a following current, and we have to figure out by how much. So just like the triangle, we measure our distance between our DR and our, so we make our little lines here. This is going to be my course made good, my speed made good. From DR to actual position, that's my current. And then from my point of origin to my DR, that's going to be my boat. My boat was going 4 knots. And now we need to figure out the rest. So, to figure out current, we are measuring the distance between DR and actual position. Our distance is 1.3, but again, that distance, that is a distance, not a speed. Just change it up here. So, we had a distance of 1.3 nautical miles. My time is the same time, 40 minutes. What is my speed? So let's do our 60D street. So speed is going to equal 60 times D over T equals speed. Plug it into our calculator. 60 times 1.3 divided by 40 gives us a speed of 1.95. So my current is 1.95 knots. So my current here is 1.95, and it is a following current, right? It's pushing us to go faster. So if my original course was 220, it is pushing me towards 220. So my set is still 220 degrees true. Now the next part is going to be finding out what our course made good and our speed made good. So I know what my course made good is because I didn't follow off my track line. So my course made good is still 220. But what is my speed made good? I need to measure that. Again, we're measuring distance, and then we need to convert it to speed. So we have a distance. My distance was exactly 4 nautical miles. So this is for my speed made good. I have a distance of 4 nautical miles. I have a time of 40 minutes. What was my speed? So we can do 60D divided by T gives us speed. We have 60 times 4 divided by 40 gives us 6. My speed, my actual speed, is 6 knots. My actual speed made good is 6 knots. And does that make sense? If I was going 4 knots and my current is approximately 2 knots, my actual speed would be about 6 knots. So yes, that makes sense. That checks out. We always want to do that common sense check. So that one, I threw you for a loop on that one. We had a following current, so it wasn't a triangle, and we didn't have it set on the hour. We had to convert all of our distances back to speed and so forth. So we got to remember to do that. And those are the tricks on, what was this? This was number 6. Nope, number 7. All right, now let's do number 8. Okay, so for number 8, we are down at the bottom right-hand side of the chart. And it says we are eastbound on the south side of Martha's Vineyard. So this up here is Martha's Vineyard. And it says we are headed around to Cape Cod. So we came out of the Vineyard Sound and we're headed up to Cape Cod. So that's up and around this side. So I just know I'm headed out this way and moving along. Here we go. Woo. Off to another chart. It tells us at 1800 we departed the buoy number 2 at the southwest shoal. So at 1800 we departed this buoy. And we are steady on course 090 at 5 knots. So let's plot our course of 090. There's our course of 090 at 1800. Let's put our DR for going 5 knots. There. So 5 nautical miles. So in 1 hour, we would travel 5 nautical miles. That's why I'm doing 5 to give us a 1900 DR position. So here is my DR position. Check that one more time. Okay. And then it told us at 1900 we fixed our position. So we actually got a position. We need to figure out what that position is. Let's plot it. It was 70, 42, 41, 42. 42.0. And 12.5. 11, 12.5. There's a line. Okay. So here is my actual 1900 position. So, zoom in on this a little bit. Okay, so this was my 1800. This is where I thought I'd end up, and I actually ended up over here. So we can create this triangle. If I connect my last position, my 1800 position, to my new position, my 1900 actual position, that gives me what my made good was. So my overground. Make sure this is lined up. Okay. So this is what actually happened overground. That's my made good. This one, I was going 090 at 5 knots, is what my boat was doing. And then if I connect my DR and my actual position and compare those two, that is my current line. So let's look at it before we decide, do our common sense. if we thought we'd be here, but we ended up over here, what is the current doing? Is it pushing me this way or this way? If I thought I'd be here and I ended up over here, it is pushing me that way. So my speed made good is a lot more than what my boat was doing. And it's pushing me slightly to the north. So it's in the east-northeasterly direction, if you will. But let's figure out by how much. So if I want to know what my current is, I measure my current line there. So we can measure it up here, and I know it's pushing me this way, so it's going to be in between 0, 0, 0 and 0, 9, 0. So we have between 70 and 80. So I have about 0.75, 0.74, something like that is my, maybe we'll just sit here. 0.75 is what I got for my current. For my drift, that's my set. Now drift, this is on the hour scale, right? This was at 1800, this is at 1900. So I can measure this distance and convert it very quickly to speed. So this distance is 1.1. So my drift is 1.1 knots. Now for my made good, what was my actual speed made good? What was my course made good? I guess we'll do speed first because I have my dividers out. So the difference, or the measuring the line between my start position and my actual 1900 position. So I get about 6.05, let's call it 6.0. So I would be making 6 knots, would be my speed made good. And my course made good, I need to do it this way. Let's see what we get. Instead of 0.90, I have 0.87. 5, 6, 7, yes. 0.87 is going to be my course made good. So that is our last one. So we can calculate what our current is by comparing our actual position and our DR position. And that will give us that vector triangle that we practiced on the radar plotting sheet. So that is assignment number 1. There are lots more of the radar plotting sheet questions on the Lapware assignment, so you can try those. And let me know if you have any questions. All right, have a good one. Bye.